Have you seen this before? You can only trace out circular motions, but you can use a series of different circles. Each one makes a small adjustment to the ones before. You can get closer and closer to your goal. It's called Fourier analysis. It is powerful and beautiful math. Let me show you some more examples. Let me show you what I've been working on recently. And I'll include a link to the source code, so you can put your own spin on things. I love this hand example. It starts like many. Move to the center, then trace out a circle. But notice the adjustments to the circle. They are not random. They are pushing up and right and down and left, rotating around. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Eventually, I start showing more circles at once. But you can still see the small adjustments racing around this path, over and over, getting closer and closer. It's mesmerizing. This one was surprisingly difficult for me. Now it turns into a square very quickly, especially considering it only has circles to work with. But notice that hole at the bottom of my red square. And notice how there's no hole in a circle. A circle is continuous. So that was a real disconnect. And before I addressed that, I had these huge shaking motions. I'm going to have to do a behind-the-scenes video where I show you some of my first attempts before I got everything right. Okay, that was way too easy. Let's try something a little more exciting. Now, I know what you're thinking. Who is Daphne Oram? And just how many silhouettes of her do we have? Well, the good news, you can learn everything you need to know about her from Wikipedia. That's where I got a lot of these pictures. I typed silhouette into Wikimedia Commons, and guess what? I got 2 different answers for Daphne here. Notice what it's doing. It's got a certain amount of detail. It sees the 2 hands out front, but it doesn't yet see them as individuals yet. It's coming. Oops, a little dent. Just keeps adding more and more detail as time progresses. The face and the hair have so much detail and it's not even trying yet. Oop, it just did something at the top of the hair. Over time, it just does more and more detail, or in technical terms, higher and higher frequency details. These are circles that are spinning around faster and faster, so that's the higher frequency. And there you have it. Do you like this one? I asked Wikipedia about space-filling curves. Can't figure out how it's so asymmetric sometimes. That fish just looked nothing like that shape, but everything else makes sense. This is the first in a series. How to draw a cat. Start with a circle, then make it a little more of an oval. Maybe center the oval just a little bit better. And then refine it to maybe more of a triangle than an oval. Yeah, this is another great example. Just keep making these small refinements to get closer and closer to the image of a cat. This picture is very simple, so you can really see it adding a little bit of detail at a time, getting closer and closer. Now this one's a little bit different. I've got this project with a lot of graphics tools, and I just added some new fonts. This one's a nice cursive font. There was a group called the Hershey fonts. Oh, this one's a fun example. The cursive works just so perfectly with this example, with this Fourier thing that we're doing. You can see it trying to go back and forth. You'd be a lot faster if you'd start from the end of every other line and start working backwards like this is. This really is a font. I didn't draw this in an art program. You could type anything you wanted. You could read these letters off of the wire. You could do anything you want. Oh, we're starting to get enough detail. It almost looks like handwriting. Those details are kind of hard for my graphics library. This video definitely pushed the limits of what I already had. I was getting a lot of glitches. Again, I have some pictures of those. Maybe I'll do a behind the scenes video with some of the outtakes. Yeah, it's at least as good as my handwriting. But you'll go from these long, fairly straight sections to very sudden curves, and my library doesn't have access to any details except it can just poll at different places. Yeah, that is readable. Like, share, and subscribe. Here's the next generation of the Hilbert curve. This one starts off with some big, obvious, wavy changes to the outside of the curve. As before, we close the curve with a straight line. That's pretty much unavoidable. Well, I hope you like the Hilberts. This is only number 2. There's more to come. And very quickly, this line adjusts itself to match this interesting curve, and almost there. Oh, this is another great example. Start with a circle as always. 1, 2, 3, 4. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. You can kind of see the circles. I mean, the way it's agitated. It's funny watching the details appear. That arm just appeared as a nub a second ago. Now it's getting thinner. Some people actually draw the circles when they do these animations. I think in a lot of cases it just comes out on its own, so I don't need to. Okay, this one just brings a smile to my face. I got the idea from an Etch-a-Sketch forum. They have the same restrictions that we do. One continuous line. There was a lot of interesting stuff out there. I took this one because it really worked well in this environment. Definitely see the circles whipping around as always. I forget what it means when there's loops in there. I learned that watching some other videos on Fourier series. Sometimes it means that certain circles are bigger or smaller than the ones that came before them. We're just pretending to learn about math here. We're really just enjoying the view. Same as always, it draws the bigger features first and then it starts filling in the details. This actually says Mac Game Store. You don't need to buy a real Etch-a-Sketch anymore. You can download an Etch-a-Sketch app. Or better yet, you can just watch me solve the Etch-a-Sketch for you in red, white, and blue. Does the terminology make sense? I'm never sure which words real people know. Amplitude is the size of the circle, the radius. Basically, how much of a difference can it make? But it's usually the amplitude of a wave, something that moves back and forth like the circle. We sort things where the biggest amplitude happens first. Here's a small twist on what we've seen before. That's the nice thing about fractals. You never really run out of them. They just get more complicated. Once again, we have this one phase where it's not quite symmetric. For the most part, it's symmetric. I'm not exactly sure what's going on, but I really do love this example. You can see it already tracing out the basic shape, and now it's just trying to clean things up. Guess it needs a little more detail. Got to fill in those little holes. And as always, a straight line to connect the two endpoints. That's just unavoidable. You can add your own images too. There's not really a GUI for it, but it's not exactly programming either. Have you ever taken a file that's not a text file and opened it up in a text editor? If so, you're 90% of the way to making your own Fourier images. If you don't know what I said, don't worry. Just keep watching the show. This works really well with SVG images. A lot of times I go to Wikipedia because they like the SVG format. I can just take a path. That's all this is, a single path. Basically a single use of the pen tool. There's other ways to make these too. This one in particular, I used my tools to flip it over. The basic thing came from Wikipedia, but I was able to manipulate it because it's just a path. And I'm accumulating tools and building tools to let me manipulate paths. Once again, there are so many good things to say about this person. I suggest you go to Wikipedia to find out for yourself. These silhouettes, they really do a nice job of showing off what's going on. They start off kind of like a potato or an egg, but they add more and more detail. Get a nose and a chin. There it is. If you know where I can get more art like this, please tell me. I'm not an artist myself. I'm just a computer programmer. I bring things to life. I love this math stuff. It's fun math. The Fourier series is beautiful and useful, but it just shows off so well. I think if someone said, Philip, make some pretty lines dance around the screen, I don't know how I would do it. I have to have Fourier telling me what to do and these nice pictures from Wikipedia. If you have more pictures like these, or if you're an artist yourself, you can draw these. I'd love to bring your work to life. Something about those little loops. They cause me so much trouble, but they look so good. Daphne's back. This is kind of neat, the way it starts off with simple shapes like that, but it starts adding a lot more detail. And you can see the details showing up slowly. Fourier analysis mostly is done with sounds. You're used to dealing with frequencies. You can turn up the bass or treble or more on your equalizer. But you're seeing the same thing here. The small details, those are high frequency issues. You need a lot of small circles to deal with them. Initially, we usually start with big circles that don't repeat very often. Eventually, you get to smaller circles that repeat faster and faster, higher frequency. And that's what fills in the higher frequency details in the fingers and the hair. Almost there, everything but those small circles and the fine details. And there it goes. Is it just me, or does that look like Bobby Hill? These silhouettes all start kind of the same. People are just ellipses, really. This one's almost too easy. You know what? We need to get back to some of those Hilberts. Here we go. Let's add some detail. In fact, let's skip some of the Hilberts. Let's go right to something complicated. This picture was almost too easy. I don't know why I even included it. Oh yeah. I just love the way this one bounces around. Looks a lot like the earlier generation. I jumped straight up to the fifth order. I think that'll be okay. This one is kind of pushing the limits. If you count the number of corners, there's almost 1,000. And you see we're using only 1,000 circles, 1,024. Does that look familiar, by the way? That almost looks like it's an earlier generation of the Hilbert. So maybe it's not so bad that we jumped right to the fifth order, because I think we're going to do some of the smaller ones along the way. Yeah, this one looks great. We are pushing the limits, as I said, but I actually made a change to my algorithm to poll at very specific places. Originally, I said if I need 1,024 things, let's just divide it into 1,024 even pieces. Yeah, that's definitely an earlier version of the Hilbert, an earlier order. It just keeps going through these. Anyway, the newer version of my software, it's just a little bit better. It knows where the corners are, and then it tries to spread out the stuff in between as well as it can. Just smoothing things out to get a better result. Wow, it's a complicated path, and I like it. It's a little bit messy. It's going to get cleaned up. Adding 81 circles at a time. This one just has so much detail. You need so many circles. Another fun one. A lot of loops. A whole lot of loops. And a lot of detail. That was easier than it looked. The songbird has an unusual start. You have this almost perfect square with that one little loop thing in it. Then, of course, it quickly starts tracing the outline of the actual bird. This was a twofer. Wikipedia had the songbird and the hawk in the same picture. Yeah, let's slow this one down a little bit. It's an interesting one. Starts again with that square, diamond or whatever, but then lots of wiggles and lots of curves. Lots of loops. I really like all the loops in this one. As always, it's not even touching the engines yet because they're too small. I need higher frequency circles. I need circles spinning faster to get that kind of detail. And they're starting to fill in. You knew they would. I'm calling this one a success. When I say adding circles, I mean that in the most literal way. The formula for a circle, it's basically sine of x and cosine of x. And all we're doing, we have a big stack of numbers, and we're just taking sines and cosines of different angles, and we're multiplying them. That's what the amplitude is. Each circle can be bigger or smaller. And that's really all the calculation is. Big stack of sines and cosines, and multiplying each one by an appropriate number. That's what all this Fourier stuff is about. It originally started with differential equations. They were trying to solve the heat equation in physics. Real things in physics are complicated, but if you can break them down into just a bunch of sines and cosines that you can add together, well, then you have a bunch of small things that you can deal with easily. Okay, one more head. I'm learning a lot about phrenology. Mostly I'm learning that people are ellipse-shaped. I'm picturing the head unwound. Like instead of going in one big circle, you can see those up and down motions on a normal graph. Then it kind of makes sense. Then you can see the high frequency and low frequency stuff the way you normally see things, the way you'd see sounds. Well, that's our last face for today. Are you ready for some serious math? Welcome to today's third and final installment of the Peano Curve. Oh, I love the way it gets straight, and there's the straight stuff next to the curves and the loops. I still don't understand that fish. That's the only part that's not symmetric. Everything else is symmetric. Yeah, this one caused me a lot of trouble. I had to fix a lot of things to get this example to work. But I really love it. And you see how it seems to be getting faster. I'm making one complete loop over and over in the same amount of time. It's just that the curve gets longer. Yeah, this is a smaller version of that curve. We've seen this before. It's a fractal. As I was saying, each generation of the fractal, it just gets a little bit longer, and it looks like it's going faster. The frequency is the same, there's just more distance that it's covering each time through. Looks a little bit crazy, a little bit electricity-like, but it smooths out. Almost there. Almost. So, what did you think? Could you see the circles? Circles on top of circles? Are there any other shapes you'd like to see? Let me know what you think. I hope you've enjoyed this ride as much as I have. This really is some interesting and useful math, but it just shows so well. There's just so many videos about the Fourier series and Fourier in general, just because this stuff looks so damn good. Check the links on the screen to see more of my work. Thanks for sticking around.